What's up guys, and welcome to this video about such a beautiful three-dimensional bar chart in Jetpack Compose using Canvas. After this video you should be able to build such a bar chart on your own and also modify it for your own needs. And let me quickly zoom in a bit. As you can see, we can also enable or disable the description. So if you prefer this kind of view, then you can turn off the description, or you can also of course turn it on. Alright, okay, I'm in an empty Jetpack Compose project, and we will also launch the app multiple times so that you can always see what we're currently drawing. And first of all, I want to add some colors here in the UI theme color file, and you can get this colors from my GitHub repository, which is linked down below, or you can also simply use your own colors. Then back in our main activity, we will first remove the default stuff and create our data class for the bar chart input. We can say data class, and normally I would put this in a separate file, but I think for the tutorial it's fine to put everything in the main activity Kotlin file. Bar chart input, and this takes the value of the bar chart element, a description of type string, and also a color of type color. And then we can create our bar chart composable, which will contain different bars, and we will make these bars also composables. So a composable function, which we will call bar chart, this will take an input list of type bar chart input, and then it will also take a modifier and the show description boolean, which indicates if we actually should show the description. In our case, in this example, the different programming languages names. Our bar chart will be a row, and this row takes our given modifier, and it has also a vertical alignment. And we will set this alignment to bottom because the bars are sometimes in a different size, or almost every time. And we want to align them at the bottom so that they start from there. And then we have also a horizontal arrangement, and the arrangement will be a space between. Then we can open the row scope, and first we need the sum of the values of all bar elements, because we want to determine the height of the different bars depending on the relative amount of their value to the total value. And we can get the sum by remember, because we make this a state so that it is not always calculated when a recomposition occurs. And we say multiple state of input lists sum of, and we pass it dot value. And then we can go over our input list dot for each. Here we get the input element, and first we need to calculate the percentage. The relative amount of the value to our list sum is equal to input.value divided by list sum.toFloat. And now we have the percentage value of the value of our input. Let me quickly define our bar composable so that we can already invoke it from our bar chart, and then pass some example values from our main activity so that we can then launch the app multiple times to see what's currently going on. We will say composable function bar. This will take a modifier, and the primary color will be of type color, the percentage will be of type float, the description of type string, and we also pass this show description boolean here. We will invoke the bar composable inside our bar chart composable then. The modifier will be modifier, and for the height we say 120 dp multiplied with our percentage value. And if we would do it like this, then all the bars, if we have for example 7 or 8 bars, will be very, very small. And this is because they share the percentage, and most of the bars will only have 15% or even 8%, 7%, and no bar will be really tall. And for that, to kind of compensate this, we will also multiply it with our input list dot size. So if the size of our input list increases, we will also increase the height a little bit so that the bar chart has taller bars, even if the percentage is shared between a lot of input elements. And then we also have the width. We will just set the width to 40 dp, and you can of course play around with these values and also make this for a responsive view, of course, but I think this would be too much for this video, so I think 40 dp is okay. The primary color will be our input.color. For the percentage, we will pass the percentage, and then the descriptioner will be our input.descriptioner. And for the show description, we also pass the show descriptioner, which we get above in here. In our main activity, I will then copy and paste some example values. You can get them from my GitHub's repository, or if you want, you can also type them off. I will go quickly over them, but I think this video should more focus on the bar charts drawing here. And so we have in our main activity a mutable state of show description. If the description should actually be shown or not, we can toggle this value now with a little switch. Then we will have a box which sets a background color, fills the max size, has some padding. The content alignment will be top center. In here we then have a column which also fills the max size, has center horizontally, and spaces its items by 20 dp. Then we have the text for the preferred programming languages and some text properties set. And then we invoke our bar chart and we pass 7 values here. We have Kotlin, Swift, Ruby, COBOL, C++, C, and Python as the different bar chart elements, and these elements get compared, so which is the preferred programming language, and the bar chart will fill the max width, and we pass the show description state down. And then we also have a row here for our switch. The text of this row is show description, and with the switch we can then toggle the show description boolean and indicate if we should actually show the description of each bar element or not. And here are just some switch colors. Okay, then we can start down here in our bar composable and start defining how the bar should actually look like. In here we will have a box because we will draw inside a box. This box takes the modifier so that the canvas can fill the max size, and the size of the canvas will then be what this modifier contains. The content alignment will be set to alignment.center, and after that we can start with our canvas. The canvas will have the modifier, as I already said, which fills the max, not width, the max size. Then we can open the canvas draw scope, and I think here's a little typo. And let's import the canvas, and then we have the draw scope. In this canvas draw scope, we now need to define some values, which helps us later when calculating the different paths of our three-dimensional bar, because each bar will have 3 different rectangles, which we can't use the draw rect for. We need to draw the path on our own, and for that we need these values we will define now, and they will make the life easier for us. We will first need the width of the canvas, which we can get from the canvas size.width. Then we need the height, which we can get from size.height. And then we need the bar width. The bar width will be our width divided by 5 multiplied by 3. I will explain this soon. We will do the same for the bar height, which will come from our height divided by 8 multiplied with 7. After that, we also need the bar height 3D part is equal to height minus bar height. Then we need the bar width 3D part is equal to width minus bar width multiplied with height multiplied with 0.002f. Alright, okay, now let's explain this. Alright, okay, I've drawn this little example here for those who are interested in what's this value is all about. If you are not interested in, you can also skip this. It takes around 90 seconds. As you can see in the picture on the left, we have the total height and the total width, which are those two values in Android Studio, the canvas width and height. And depending on how much we want to make this three-dimensional, how much we want to show the top side and the right side, we will divide our width and our height by these values. So divided by 5 multiplied with 3, or divided by 8 multiplied with 7. Because if you change this value, then you will make this bar width and bar height larger, and you will shrink the view on the left side and on the top side. And you can play around with these values. It gets super clear if you just try this out, and then you can see it. And I've just experimented it a little bit with these values, and for me, these values are really fine and making a really good look. And then we also have the bar height 3D part, which is calculated from our high minus our bar height. This is this two arrow here, this double arrow up here. And then we also have the bar width 3D part. And this is multiplied with a little bit of modified version here, because I've experienced that if we would just use the width minus the bar width like we do with the bar height 3D part, then this would not look that good when we have small bars, because this small bars would also get the same 3D width like the big ones, like the tall ones get. And then, yeah, this would not look that good. But I just recommend you to play around with this. Things will get super clear if you try this on your own. And yeah, I think this is enough of theory. Now let's draw all those paths. The first path we want to draw is the path for the two-dimensional view rectangle. If we would be only interested in a two-dimensional bar chart, then this path drawing would be enough. And we can achieve this by var path is equal to path apply. And in here, we first need to move the cursor where the drawing should start. We will say for the x value 0f, and for the y value, we will say height. Because, let me quickly show you this on the picture. I hope you can see my mouse. I hope it's not too small. The canvas 0x and 0y is at the top left, where my mouse actually is. And we want to start drawing at the bottom left, because we want to draw this red rectangle. So we move the cursor to the bottom left, and from here we can start drawing now. And the bottom left is also our canvas height, because as you can see, this double arrow is our height. Let's go back to Android Studio and draw the first line. We will say line 2 bar width, and we also pass the height, because the height stays the same. Let me also go back to the picture. I will just show you this once, and after that we will continue drawing. But I think this is important to understand, otherwise you would just type this off here. We had to move this cursor down here at the bottom left. And now we will draw this line where my cursor is now. And this line is for the x value our bar width, because as you can see here, this double arrow for the bar width, and the height stays the same. So we again pass the height for the y value. Let's go back to Android Studio. We set another line to. The bar width remains the same, but this time for the y value we have our height minus our bar height. Let's go one last time back to our picture. We were at this point the last time, and we want to now draw the line up here, and the bar width is fine, but now we need a new value for the y. So we have the height minus our bar height, because as you can see here, the large double arrow for the height minus the bar height is this point here, because you need to think of the start of the canvas is at the top where the y value is 0. So the difference between our height and the bar height is this point here. Okay, I hope this got clear. And then we set another line, 0f, and we say height minus the bar height. So we are at the top left. And for the last line, we can simply call close, and then Canvas does the rest for us. Then we can say draw path. We pass our path. Then the brush will be brush.linear gradient, and for the colors we pass a list of colors. And the first color will be gray, and the second color will be our primary color. Then we can launch this and have a look at the different bars. And I think this looks quite cool so far. As I already told you, if you are only interested in the two-dimensional bar chart, then this is enough. And now we will draw the additional two rectangles, which will then cause the three-dimensional view. Then we can again say path is equal to path.apply. And we move the cursor this time to our bar width. And for the y value, we will say height minus bar height. Then we will draw a line to bar width 3D part plus bar width. and for the y value we will pass 0. Then line 2, bar width 3D part plus bar width, and for the y value we will say bar height. And the last line will be set to our bar width, and for the y value height. And then we can again say close, and we can copy and paste this draw path and paste it down below. This time we switch the gradient colors because then we get this real three-dimensional view because the color differences. Then we can start and have a look again. And as you can see, we have drawn the right rectangle, and this looks quite cool so far. And I would also like to show you what happens if we wouldn't use this multiplication here, because this kind of looks totally random. But let me quickly remove this and start this again. Then you can see, if you have a closer look, that like this, on the large bars, the tall bars, it looks quite cool, but on the small bars, the view on the right rectangle is just too big. We see too much of the right side here, and yeah, we can avoid this with this multiplication. Let me quickly start this again, and yeah, then you can see it really looks better now. Below our last drawn path, we can then draw the third path is equal to path.apply again. We move the cursor, this time to 0f and our bar height 3D part. Then the first line will be set to bar width and bar height 3D part. The second line, let me scroll up a little bit, will be set to bar width plus bar width 3D part. And for y we pass 0f. The last line will be drawn to bar width 3D part, and for y 0f as well. And then we can close it and copy and paste the draw path again. Change this to colors here to gray and orange in this order. And then we can start it again and have a look at our different bars. And yeah, I think this looks quite good. And yeah, I choose orange here. This was wrong. Of course, this needs to be the primary color, and then the top side should be also in the same color than the rest. Okay, this looks fine so far. The only thing that's left is the percentage drawing at the bottom, and also the functionality to show the description of each bar element. We need to use the native canvas for drawing a text, so we will say draw context.canvas.nativecanvas.apply. And then we will invoke this function draw text, and first we will pass the text, which we will get from our percentage, multiply it with 100, round this to an integer, and then we append this percentage sign. Then for the x positioning, we will say bar width divided by 5f, and for the height, we will say height plus 55f. Also, these are values I played around with. If you want to make this responsive, then you need to apply additional logic, but yeah, this is also possible. Then we say android.graphics.paint.apply, and for the color, yeah, let's invoke it like this. We will say white to RGB. The text size will be 11.dp.2 pixel. And we also make this bold with this property parameter. Then we can launch this and have a look at the different percentage texts. Yeah, I think this looks cool. The only thing that's left is our show description functionality. We will show the description if this boolean is actually true. And we again need the native canvas for drawing a text. We want to rotate this text so that it is not shown horizontally. And for the degrees, we pass minus 50f. We also pass a pivot, and this will be an offset. And the offset's x value will be our bar width 3D part minus 20, and the y value will be 0f. And then we can open this rotation block, and in here we can then draw our text. We will say draw text. For the text, we will pass the description. The x value will be 0f, the y value will be also 0f, and then we again need the Android graphics.paint version and say apply. The color will be white.2RGB. The text size will be a little bit bigger, 14 dp.2 pixel, and we also make this bold. And this should be it. We can try to start it and check if the functionality is also working. The show description is turned off by default. When we turn it on, then you can see, let me zoom in a little bit, that they get drawn very nicely above each bar, and we can also make them invisible and visible again. So I think everything works perfectly fine. All right, okay, this was it for this video. I hope you enjoyed it and you can apply this bar chart, which is really cool, I think, on your own project. And also let me know if you kind of modify it and make a better version, because this is a basic version. This can be expanded and modified in so many ways. So it would be really cool if you have some additional ideas and use this as a basis and then do your own thing and your own logic on it.